Imagine standing at the edge of Antarctica. In front of you stretches a frozen wilderness larger than the United States and Mexico combined. Towering glaciers rise from the horizon. Ice cliffs hundreds of feet high meet the ocean. Winds howl across a landscape so cold that exposed skin can freeze within minutes. It looks eternal, unchanging, timeless. Yet beneath this frozen silence, a fierce scientific debate has been unfolding. For years, headlines have warned that Antarctica is melting. Satellite images have shown shrinking ice shelves. Scientists have reported rising sea levels. Climate reports have described a continent under pressure. Then suddenly, another set of headlines appeared. Antarctica is growing. Antarctic ice reaches record levels. The frozen continent is expanding. For many people, these reports seemed impossible to reconcile. How can Antarctica be melting and growing at the same time? How can scientists warn about ice loss while some measurements show increasing ice? And perhaps the biggest question of all, is Antarctica actually getting bigger and bigger? The answer is one of the most fascinating stories in modern science, because Antarctica is not behaving the way most people imagine, and understanding why requires a journey into one of the most extreme environments on Earth. To begin, we need to clear up a common misunderstanding. When people talk about Antarctica growing or shrinking, they are often talking about two completely different things: land ice and sea ice. At first glance, they appear identical. Both are frozen water, both are white, both cover enormous areas. But scientifically, they are very different. Land ice is ice sitting on the continent itself, glaciers, ice sheets, snow that has accumulated over thousands of years. If this ice melts and flows into the ocean, sea levels rise. Sea ice is different. Sea ice forms when ocean water freezes. It floats on the surface of the sea, like ice cubes floating in a glass of water. When sea ice melts, it contributes very little to sea level rise because it was already floating. This distinction changes everything, because when headlines claim Antarctica is growing, they are sometimes referring to sea ice. When headlines claim Antarctica is shrinking, they are often referring to land ice. And once you understand that difference, the mystery becomes much clearer. But the story gets even stranger, because Antarctica itself is not one uniform block of ice. It is divided into different regions, and those regions are behaving very differently. The largest section is East Antarctica. This is the giant, the heavyweight, the portion containing the majority of Antarctica's ice. Then there is West Antarctica, smaller, more vulnerable, and significantly warmer. Think of Antarctica not as one frozen continent, but as several different systems operating under different conditions. In some areas, ice is accumulating. In others, ice is disappearing. Both can happen simultaneously, and they often do. To understand why, imagine a giant bank account. Money flows in, money flows out. What matters is the balance. If more money enters than leaves, the account grows. If more money leaves than enters, the account shrinks. Antarctica works in a similar way. Snowfall adds ice. Melting removes ice. Icebergs breaking away remove ice. Glaciers flowing into the sea remove ice. The overall size depends on which side wins, and that balance changes constantly. Now here's where things become fascinating. Warmer air can sometimes create more snowfall. That sounds backwards. After all, warmth melts ice, right? Usually, yes, but warmer air can also hold more moisture. More moisture can produce more snow, especially in extremely cold regions where temperatures remain well below freezing. Scientists have observed periods where parts of Antarctica received unusually high snowfall. These snowfalls added enormous amounts of ice to the continent. In some regions, the gains temporarily offset losses occurring elsewhere. For a time, certain satellite measurements even suggested portions of East Antarctica were growing. This led to confusion. Some people interpreted the findings as proof Antarctica was not melting. Others claimed climate change theories had been disproven. But scientists urged caution, because Antarctica is enormous. And short-term growth in one region does not necessarily reflect what is happening across the entire continent. Imagine weighing a person who gains 5 pounds in one arm while losing 20 pounds overall. Focusing only on the arm would create a misleading picture. Scientists therefore look at the entire system, and when they do, a more concerning trend emerges. Over the last several decades, Antarctica has generally lost more ice than it has gained. Not everywhere, not every year, but overall, the strongest losses are occurring in West Antarctica, and that region worries researchers more than almost any other place on Earth. Why? Because West Antarctica sits in a uniquely dangerous position. Large portions of its ice rest on bedrock located below sea level. That means warm ocean water can attack the ice from underneath. This is one of the most important discoveries in modern polar science. Many people imagine Antarctic melting happening from above. The sun shines, ice melts. Simple. But some of the most significant melting is occurring from below. Warm ocean currents move beneath floating ice shelves. These currents gradually erode the ice, like termites weakening the foundation of a house. The structure may appear stable, until suddenly it isn't. Ice shelves play a critical role in Antarctica. They act like giant barriers. They hold back glaciers behind them. When an ice shelf weakens or collapses, glaciers can accelerate toward the ocean. And once that process begins, ice loss can increase dramatically. Scientists have witnessed this phenomenon multiple times. Some ice shelves that existed for thousands of years have disappeared within weeks. Massive structures larger than cities shattered into countless fragments. Satellite images captured scenes that looked almost unbelievable. Entire sections of ice simply disintegrated. These events became warning signs, not because they immediately raised sea levels dramatically, but because they revealed how quickly change can occur once critical thresholds are crossed. Still, the question remains, if Antarctica is losing ice overall, why do reports sometimes claim it is getting bigger? The answer often lies in sea ice. Unlike land ice, Antarctic sea ice behaves in highly complex ways. Ocean currents influence it, wind patterns influence it, temperature influences it, storm systems influence it, and these factors can sometimes push sea ice to expand even while land ice declines. For years, Antarctic sea ice puzzled scientists. While Arctic sea ice generally declined, Antarctic sea ice displayed more variable behavior. Some years saw increases, some years saw decreases. The pattern appeared inconsistent. Then more recently, dramatic declines occurred. In fact, Antarctic sea ice reached some of the lowest levels ever recorded by satellites. Researchers were stunned. Some described the changes as unprecedented. The same continent once cited as evidence of expanding ice suddenly showed record losses in sea ice coverage. Nature, it turns out, rarely follows simple narratives. Another reason people become confused is scale. Antarctica contains about 90% of the Earth's ice. That number is almost difficult to comprehend. The continent is so massive that even substantial changes can appear small when viewed from space. A glacier may lose billions of tons of ice, yet from orbit, the continent still looks overwhelmingly frozen. This can create the illusion that little is changing. But scientists measure far more than photographs. They use satellites capable of detecting tiny changes in elevation. They use gravity measurements to estimate ice mass. They use radar systems to track glacier movement. They monitor snowfall, ocean temperatures, wind patterns, sea ice extent. Thousands of data points combine to reveal what the human eye cannot easily see. And the picture emerging from these observations is complex but increasingly consistent. Parts of Antarctica are growing, parts are shrinking, but the shrinking regions are generally losing more ice than the growing regions gain. That distinction is crucial. Yet there is another fascinating twist. Not all ice growth is necessarily good news. Remember how warmer air can produce more snowfall? That means increased snowfall can sometimes occur because the atmosphere itself is changing. In other words, ice gains in some regions may actually be connected to the same climate processes driving losses elsewhere. Nature is full of these paradoxes. One effect can produce seemingly opposite outcomes depending on location. This is why scientists often caution against drawing conclusions from isolated observations. A single iceberg, a single snowstorm, a single glacier, a single year. None tells the whole story. The true picture only emerges when examining the continent over decades. And Antarctica is not just important because of ice. It influences the entire planet. The continent helps regulate global climate. Its ice reflects sunlight back into space. Its surrounding oceans drive major circulation patterns. Changes there affect weather systems thousands of miles away. What happens in Antarctica does not stay in Antarctica. It affects everyone, from coastal cities, to farming regions, to global shipping routes, to ecosystems across the world. Perhaps the most remarkable aspect of this story is how much remains unknown. Antarctica is one of the least understood places on Earth. Researchers continue making discoveries beneath the ice. Hidden mountain ranges, subglacial lakes, ancient landscapes buried for millions of years, entire ecosystems existing in extreme isolation. Every year, new information reshapes our understanding. This means science is not standing still. What researchers believed 20 years ago is not necessarily what they believe today, and what they believe today may evolve as new evidence emerges. That is not weakness. That is how science works. Evidence accumulates, understanding improves, models become more accurate, questions lead to better questions. So, is Antarctica actually getting bigger and bigger? The most accurate answer is no, at least not as a whole. Certain regions have gained ice at different times. Certain snowfall events have temporarily increased ice accumulation. Certain sea ice measurements have shown expansion during specific periods. But when scientists examine the entire continent over long timescales, Antarctica is generally losing more ice than it gains. Yet the story is not as simple as Antarctica is melting, because some parts are growing, some parts are shrinking, some changes are driven by snowfall, others by ocean currents, others by atmospheric conditions. It is a continent filled with contradictions, a frozen giant behaving in ways that continue to surprise even the experts studying it. And perhaps that is the real lesson. The world is often more complicated than headlines suggest. A single sentence cannot capture the behavior of an entire continent. A single statistic cannot explain millions of square miles of ice. Reality exists in the details, and Antarctica is one of the most detailed, complicated, and fascinating places on Earth. A place where growth and loss occur simultaneously, where snowfall can increase during a warming world, where ice can melt from below instead of above, where answers often raise even bigger questions. The frozen continent remains one of humanity's greatest scientific mysteries, and the more we learn about it, the more extraordinary it becomes. If you enjoyed this documentary, leave a comment below with your answer to this question. Were you surprised to learn that parts of Antarctica can grow while the continent as a whole loses ice? And if you want more fascinating documentaries that uncover the truth behind the world's biggest mysteries, don't forget to like, subscribe, and turn on notifications so you never miss the next story.